Have you ever wondered if AI could really read your mind? It's an intriguing question, isn't it? The thought of artificial intelligence being able to decode our deepest thoughts and perceptions has been a captivating topic for both tech enthusiasts and neuroscientists alike. It's the intersection of two fascinating fields, artificial intelligence and neuroscience. Imagine AI algorithms that can tap into our neural networks, deciphering the intricate patterns of electrical activity that represent our conscious and subconscious thoughts. It's a concept that's as thrilling as it is terrifying. But is it really possible? Can a machine truly understand what's going on inside the human brain? This is not just a question of technology and its capabilities, it's also a question of ethics, of privacy, and of the very nature of our consciousness. It's a question that has sparked countless debates, fueled numerous research studies, and even led to the publication of several scientific papers claiming to have made breakthroughs in this area. Well, recent research might just have an answer for us. A series of scientific papers claimed that AI can read minds using EEG data, but is this true? Let's delve into this fascinating subject. The papers in question proposed that artificial intelligence, when paired with EEG or electroencephalogram data, could unlock the secrets of the human mind. They suggested that AI, a system capable of learning and problem-solving, could decode human thoughts from the electrical activity recorded by EEG. This technology, they claimed, could potentially allow us to visualize thoughts, memories, and even dreams. It's a concept that sounds like it's straight out of a sci-fi movie, isn't it? But before we get too carried away, let's introduce some skepticism into this narrative. Researchers at Purdue University decided to investigate these bold claims. They embarked on an analytical journey scrutinizing the methods and data used in these papers. Their findings were quite revealing. The Purdue team discovered significant flaws in the datasets used in these studies, which led to false conclusions. The EEG data, it turns out, may not be as reliable a source of mind-reading information as we'd like to believe. The researchers highlighted the importance of robust experimental design, especially in cross-disciplinary research where the stakes are high and the potential for misunderstanding is great. This doesn't mean that AI and neuroscience can't work together to decode the human mind. It's just that this process might not be as straightforward as some have led us to believe. The Purdue study doesn't debunk the potential of AI in neuroscience, rather it calls for a more rigorous, careful approach in this fascinating field. Turns out the reality of AI mind reading might not be as straightforward as we thought. Purdue University researchers decided to dig a little deeper into these mind-reading claims. They found themselves at the intriguing intersection of artificial intelligence and neuroscience, a junction where two distinct disciplines converge to explore the mysteries of the human brain. This team of dedicated researchers embarked on a journey to scrutinize the credibility of numerous published papers that claim to decode visual perception from brain waves using electroencephalography or EEG data. But what they uncovered were not the secrets of mind reading, but rather a series of flaws within the dataset used in these studies. Their findings revealed that the EEG data, which was the foundation for these mind-reading claims, was riddled with inconsistencies and errors. These flaws skewed the results, leading to false conclusions and giving rise to the illusion that AI was capable of reading minds. However, their study wasn't aimed at debunking the potential of AI in reading minds. Rather, they sought to emphasize the importance of proper experimental design in cross-disciplinary research. Their work serves as a reminder that the path to any scientific breakthrough is paved with rigorous research methods and meticulous data analysis. Indeed, their findings highlight the need for a more robust approach in the field of AI and neuroscience. It's a call to action for researchers everywhere to ensure the validity and reliability of their data before drawing sweeping conclusions. So does this mean that AI cannot read minds? Well, not exactly. These findings do not necessarily negate the potential of AI in decoding brain activity. Instead, they underline the importance of ironclad research methods and accurate datasets in the journey of discovery. So, the door isn't closed on AI mind reading, but it's certainly not wide open either. You might be wondering, why does this even matter? Well, think of it this way. The intersection of artificial intelligence and neuroscience is like a newly charted territory. It's unexplored, filled with possibilities and teeming with potential, but it's also fraught with pitfalls, and false claims can be one such pitfall. In an age where we are increasingly relying on AI, the accuracy and reliability of research in this field are paramount. We're not just talking about Siri mishearing your dinner order here. The implications are far more significant. We're talking about the potential to decode visual perception from brain waves to essentially read minds. Imagine for a moment that these claims were taken at face value, that we started developing technologies based on flawed research. It's like building a house on a weak foundation. Sooner or later, it's bound to collapse. And when it does, it doesn't just impact the scientists who conducted the research or the AI specialists who developed the technology. It impacts everyone who uses that technology, and in today's interconnected world, that could be anyone, anywhere. That's why it's so important that the research in this field is accurate, reliable, and conducted with proper experimental design. It's not just about debunking false claims or correcting inaccuracies. It's about ensuring that the technologies we develop are safe, reliable, and truly beneficial. And let's not forget the psychological impacts of false claims. They can erode trust in science and technology, create false hopes, and even lead to unwarranted fears. That's why it's so crucial to approach this field with caution, with skepticism, and above all, with rigorous scientific methods. So, while the idea of AI reading our minds is fascinating, it's crucial that we approach this field with caution and rigorous scientific methods. So, where does this leave us in the quest for AI mind reading? In the wake of these findings, it's clear we're standing at the precipice of uncharted territories where the intersection of artificial intelligence and neuroscience lies. This is not the end, but rather a beginning, a call to action for more rigorous, thorough, and interdisciplinary research methods. The future of research in this field is not without challenges. The task at hand is not a simple one. It's not just about debunking flawed studies, but also about forging ahead with fresh perspectives, innovative approaches, and robust methodologies. We need to remember that the human brain is an incredibly complex organ. Decoding its intricacies with machine learning algorithms is no small feat. The science behind mind-reading AI needs to be as intricate as the organ it seeks to understand. This is where cross-disciplinary collaboration becomes crucial. The blending of expertise from different fields, neuroscientists with their deep understanding of the brain, data scientists with their proficiency in handling large data sets, and AI specialists with their knowledge of machine learning algorithms can bring about a more holistic approach to the challenges we face. The path ahead is not just about creating AI that can read minds, but also about understanding our own minds better. AI can be a tool to unravel the mysteries of the human brain, to shed light on how we think, learn, perceive, and remember. And as we traverse this path, we mustn't forget the importance of skepticism and critical thinking. It is through questioning, testing, and retesting that we can ensure the validity of our findings and avoid the pitfalls of false conclusions. In this quest, we are not just researchers, but also explorers, venturing into the unknown, driven by curiosity and the pursuit of truth. The intersection of AI and neuroscience is an exciting frontier. But as we continue to explore, we must remember to always question, always test, and always strive for the truth.